it.
Hey, these refreshments are a great idea, Frank.
Well, you have Martha and Sue and Todd to thank for the refreshment.
Okay. Thank you.
And if you guys want to do it again, somebody else might bring the goodies next time.
Are we going to do any math?
Why, sure we are. I just thought it might be interesting to sit around and kind of talk informally about math. But I did ask Martha and David to prepare something so we wouldn't risk an entire evening of silence.
I don't think you have to worry about that. We can usually manage to talk.
Yes, I know. But let's try to make it about fractions and such like tonight, okay? Who knows what most people think fractions are?
Part of something?
Okay, let's explore the idea of fractions as parts of things. Who would be willing to play the part of someone who doesn't understand anything at all about fractions?
I think I'd be real good at that part.
All right, Martha, and someone who will explain to her everything about fractions as parts of things. Who wants to play the part of the teacher?
I'll be the teacher, if I get a key to the faculty lounge.
Well, I'll tell you what, Todd. This is kind of a make-believe classroom. Martha's a pretend student. You're a fantasy teacher. You can have a key to match, okay?
Okay, but I need a chalkboard, and no teacher can teach without a chalkboard.
You got it.
Okay. Well, let's see now. Martha, a fraction is a number that tells about something that's less than 1. Let's say that this is a pie. Now, if I cut this pie into 2 pieces, each piece is called 1/2. That would be 1 piece for me and 1 piece for you.
Why is it called 1/2, teacher?
Because I said so, kid.
Well, if you cut it into 3 pieces, then what do you call it?
It would be called 1/3.
Then how come you don't call it 1/2 when you cut it into 2 pieces?
Well, because I'll ask the questions here. Now, look here, kid. A fraction is made up of 2 numbers. The bottom number is called the denominator. That means name. The denominator tells us how many pieces are in the whole thing.
What old thing?
Any whole thing, kid.
Oh.
Now, suppose I cut this pie into 8 pieces. The denominator that tells us about that is 8. Now, the number on top, the numerator, tells us how many pieces of the whole we're considering at that time.
What time?
Any time, kid. Now, I'm going to shade 7 of the 8 pieces it takes to make a whole. That would be 7/8. That's the meaning of 7/8. Now, here is another way to show sevens. And here is halves again. And you'll notice that the shaded parts, and I'll shade these 3, the shaded parts and the unshaded parts added together equal the total number of pieces in the whole thing, like 3/7 shaded and 4/7 unshaded means that there are 7/7 in the whole thing. Got that?
Mm-hmm.
Now, in order to make a whole, the numerator can never be bigger than the denominator. And you'll notice that I only added the numerators and not the denominator.
Teacher, I was in a restaurant the other day, and they were cutting a pie into 6 pieces, and there were 20 or 30 pieces of pie on the shelf. Now, how's that possible?
Good question, kid. They had more than 1 pie. Let's say they had 26 pieces. Okay? That would be 4 whole pies and 2/6 of another pie.
Really, teacher, shouldn't that be 1/3 instead of 2/6?
You're right. There.
All right. Very good. Good,
Thank
you two. That was very good. You really hit on
Wonderful.
some important points in there, you know. Who can tell us 3 important things that they mentioned?
Well, Todd explained what numerator and denominator mean.
That's right, the terms of a fraction. Right, good. Anything else?
Well, he said that for a whole number, the numerator can't be bigger than the denominator.
That's exactly right. In fact, in a whole number, the numerator and the denominator are exactly the same.
They said something about the way a mixed number is like a fraction, you know, when they were talking about the pies.
Hey, you guys were listening after all.
Sounds like you know your basic stuff here. I hope this evening what you'll find out is that a solid foundation in math ideas will help you later on to make quantum leaps in your understanding.
What's a quantum?
He'll ask the questions, kid.
A quantum, Martha, is a very large and unexplained, maybe great, only bigger.
Well, thanks, Frank. I'll remember that.
Sue, can you tell us another meaning of fraction?
Sure. A fraction can mean the numerator divided by the denominator.
Well, now, how does that apply?
Well, I guess I notice it most when I take a whole number and divide it by another whole number that doesn't come out even. You want me to show you?
That's right. Here's the chalk.
Okay. Well, Todd and Martha showed us the example of what I'm talking about with the pie. If you take 26, divide it by 6, you get 4, with a remainder of 2.
A remainder of what?
A 2. When you divide 26 by 6, whatever left over you divide by 6 as well. So 2 divided by 6 is 2 over 6, which can be reduced to 1/3. The principle's all the same.
Good, good. Now, does that mean that if you have 4/5, that also means 4 divided by 5?
Uh-huh.
And if you have 2/9, that's the same thing as 2 divided by 9?
Sure.
Well, then what is A divided by B?
A over B.
Huh? A over B.
Ta-da!
Now,
Got
that
it?
is one of those leaps of understanding that I was talking about. There's nothing mysterious about that. All right. Shall we get David to tell us about equivalent fractions?
Oh, we've heard him tell us before. Boy, have we heard him tell us before.
Oh, well, then maybe you'd like to tell us, Bill?
Oh, no. Okay. All right. Every fraction belongs to its own family of equal fractions. 1/2 is equal to 2/4, 3/6, 4/8, and so on. That's David's favorite definition. I guess because you can see a lot of the relationships in the numbers that you need in lots of things you do with fractions and mixed numbers.
Well, just to kind of refresh our memories a little bit, could you show us some examples?
Yeah, right. People in shoes is a good example. One person needs 2 shoes. 2 people need 4 shoes. 3 people need 6. 4 need 8, and so on. Now, every member of this family shows the same rate of sharing.
Right. Now, why is that an important idea?
One reason is to understand that when you go this way, you're multiplying, and this way you're dividing.
Okay, now how does that help?
Well, it helps you find common denominators. If you can find members of 2 families with the same denominators, you can add or subtract them.
Okay, good. That's one advantage. What's another one?
Well, it gives you experience in finding the value of the fraction in its lowest terms.
What do you mean?
Well, starting here and going in this direction is a process of multiplication. Now, reducing to lowest terms is just the opposite of that process. In reducing to lowest terms, you try to find the simplest member of the family. Now, if I built several of these fraction families, and believe me, Frank, I have, the first fraction in each family would be in lowest terms.
Good, good. Does everyone understand what he's saying? Good,
Do we?
good.
So something else. The same kind of relationship holds with mixed numbers. You can build the same kind of fraction family around, say, 9 halves or something.
Good, good. Show us.
Oh, all right. 9 halves equals 18 fourths equals 27/6 equals 36 eighths. Now, man, and so on. If you ever came upon a fractional expression or statement like 36 eighths, and just followed the opposite process that I just went through and came back this way, you'd end up with 9.5. Of course, that's the same as 4.5.
Good, good. Now, are there any other relationships in this family method of thinking about fractions?
I'm sure there are, Frank. I can't think of any right now, but, you know, they're bound to be.
Okay, okay. Can anybody else think of anything to add to what Bill told us? Huh?
I think I deserve another cookie.
You bet you do.
I deserve a cake.
Well, all right, then let me try to show you something that just might give you something to think about, okay? Let's say we pick up any two members of an equivalent family, say 2/3 and 4/6. If we multiply the denominator of one by the numerator of the other and then do the same thing to the other two, you see what we get? Huh? All right, let's do another one just to see. Say 3/8 and 6/16. Okay, 6/8 are 48, and 3 times 16 is 48. Beginning to see a pattern emerge here? Okay, let's try one that are not equivalent. Let's say 3/4 and 5/8. 4 times 5 is 20, and 3 times 8 is, you see?
Yeah.
Now, what good is that?
I never noticed that before.
Well, what good is it?
Well, it would be a way to check to see if two fractions are a member of the same family.
That's very good. I'm beginning to see a gleam in Sue's eye. She has something she wants to tell us, but it'll have to wait till later on.
Are you reading minds again?
Well, not exactly.
Well, can I just say that most often in math that you need to find a member of a family that you don't expect to be related?
No, you can't say that.
If one eye is closed and the other is open, what expression would you use to tell me the part of the whole or the amount of eyes closed compared to the total number of eyes? Well, since I have only 2 eyes and one was closed, the expression would be 1 to 2, or 1/2. The fraction 5/8 would mean 8 parts in the whole and 5 of them are being considered. Another example would be if I have 5 fingers on this hand and I hold up 2 fingers, what would the expression be for those fingers we are considering? The answer would be 2/5, or 2 of 5 fingers are being shown. Let's look at this example. Here you see 7 separate objects. There are 3 red objects compared to the total 7. This comparison, expressed as a fraction, would be 3/7. Fractions are also a ratio of one number divided by the other. For example, 3/7 is equal to 7 into 3, and 5/9 is equal to 9 into 5. By the same token, the reverse is true also. 3 divided by 8 could be expressed as 3/8. Also, remember that fractions and mixed numbers are part of a family of equal fractions. 1/2 is equal to 2/4, is equal to 3/6, is equal to 4/8, is equal to 5/10, etc. 4.5 is equal to 9/2, is equal to 18/4, is equal to 27/6, is equal to 36/8, and so on. Now, back to the class.
Well, this has been a very good discussion. Martha had an experience recently that I think we all might find interesting. I've asked her to tell us about it. Martha?
Well, most of you know how much trouble I've been having adding and subtracting fractions, so I'm not going to bore you with that. But what I really wanted to say was that I was pretty scared because I knew I had to take this test for a new job that I really wanted, and I knew that there were going to be fraction problems on it. So I got up my courage, thanks to Sue, and went to David's office and asked him for help. And he showed me this great new method of adding and subtracting fractions where you don't even have to find a common denominator in order to start.
It's called general case addition and subtraction of fractions.
Yeah. What you do is you look for this pattern in the problem, and then you just write down the answer. It's pretty mental.
But how's that possible?
Let me show you. Okay, let's say you take 1/2 plus 1/3. Now, right off, I know that the answer is going to be 5/6.
How do you know that?
Just by looking at it. You see, there's a 5 and a 6 in the problem. Now, by developing your own system for finding this kind of answer, pretty soon you'll be able to find the answer to any kind of problem.
You know, she's right. Just looking at it, I can see a 5 and a 6 in the problem.
True.
Does that always work?
Sort of.
Well, now, if you want to know the whole system, Martha or I will be glad to show you. Now, Martha, what happened when you went to take the test?
After David showed me how to figure out this new method, I went home and I just practiced like crazy. I mean, I must have done these problems hundreds and hundreds of times. I just kept at it until I was so good that I couldn't even believe it was me. Well, the day of the test came, and I had never felt better or more prepared for anything in my whole life. I got to the testing center, and the lady in charge handed me the test booklet and showed me where to sit to take the first part. Well, just as I figured, the first part was on reading. I mean, not just any old reading, but the kind of stuff you have to read in order to work in that office. I knew I was going to do fine on this part. The second part of the test, the office skills, that wasn't real hard either. It mostly involved just filing things. And then came the arithmetic section of the test. The lady handed me the test booklet and told me to do as many of the problems as I could in the time allowed. I breezed right through the first 2 sections of the test. They were just simple arithmetic, you know, mostly addition and subtraction, some multiplication and division. Then came the fractions, and I was just dying to do them because I thought for the first time ever I could handle them. Well, I turned the page, and I just about freaked out. There were fractions on that page, all right, but there were also mixed numbers. Mixed numbers? I hadn't even thought that mixed numbers might be in that section. I know this sounds dumb, but my palms began to sweat, my throat went dry, and I thought to myself, Martha, you dummy, you blew it. I mean, I hadn't practiced mixed numbers at all. Then I remembered what David had told me. He said, Martha, if you forget, you can recreate this whole system for yourself. So I forced myself to calm down by thinking, well, maybe I could solve these problems after all by using what I knew already and trying to put them together to create a new system of my own. So I went through the test doing the regular fractions, and that went real fast. Then I went back to the beginning and started looking at the mixed numbers. Now that's when it dawned on me. I mean, mixed numbers are just whole numbers and fractions combined. So what it seemed like I should do is to solve the whole number part of the problem, and then the fraction part, and then put the 2 of them together. So that's what I did. The first problem, I think, was 4 1/2 plus 2 1/3. Now, I knew immediately that 1/2 plus 1/3 was 5/6, just like up on the board here. And anybody knows that 4 plus 2 equals 6. So the answer, 6 and 5/6, just jumped right off the page at me. It was just amazing. I must have had, 20 examples of these mixed numbers to work. But because I'd saved so much time going through the test and doing the easy ones first, I had plenty of time to do the whole test. I felt real proud of myself. I mean, you know, not just because I'd done so well, but because I did it by using a system that I had dreamed up by myself. Oh, I know I didn't invent this system, but I had figured it out. So I think what I really want to say at this point is practice. Whatever you want to learn, just practice, practice, practice. Because you never know when the day's going to come when you have to take 2 things you know, put them together, and use them to help you solve a third problem. Well, I guess that's it.
Well, that's very, very good advice, Martha. Thank you. Thank you very much. Now, can all of you see how Martha took 2 basic ideas and came up with a new solution?
Yeah.
New to her, at any rate.
Yeah.
Nobody can teach us everything that we need to know. We all need to develop the talent for inventing things from the information that we already have locked up in our brain someplace. Well, listen, let's take another little refreshment break, and then we'll get into David's big production.
It appears as though Martha has found a handle on mixed numbers and is feeling more confident, especially now that she did so well on the test. Martha found that a mixed number is expressed as a whole number and a fraction. To calculate, it is possible to solve the whole number and the fraction portion separately and combine the answers. For example, 4 1/3 plus 2 1/2 can be solved by doing the following. 4 plus 2 plus 1/3 plus 1/2 is equal to 6 5/6. The example 3 2/3 plus 2 1/4 could be solved as 3 plus 2 plus 2/3 plus 1/4 is equal to 5 11/12. Or 3 2/3 plus 1 3/4 is equal to 3 plus 1 plus 2/3 plus 3/4, which is equal to 4 17/12, which equals 4 plus 1 5/12, which equals 5 5/12. It might be a good idea for you to take Martha's advice and practice, practice, practice. By the way, can you remember the system for direct addition and subtraction of fractions? Remember a couple of Martha's models. 1/4 plus 1/3 equals 7/12, and 3/4 minus 2/3 equals 1/12. Don't forget to cross-multiply the numerators for your new numerator. Let's go back to the classroom and see what David is up to.
Well, David, are you about ready to go?
Just about, but I think I may need some more clear space up here.
Could we move this table back, give David some more room? Okay, good.
Yeah, looks pretty good.
Folks, I've asked David to come in this evening and bring his collection of special math instruments. I think he could use them to show us that ideas can pop up sometimes when you least expect them. David?
I don't suppose there's any such thing as a Hall of Fame for mixed numbers. But if there is, this is my nominee as the #1 mixed number in the world, pi. Pi is a special number that's been given the name of a Greek letter. Nobody knows how long pi's been around, but we think that ancient civilizations used it. And pi seems to disturb people for some reason. So I thought it might be a good idea to talk about it today. We all know about this compass. The kind we use to make little circles with. But just for this class, I made this big compass. I'm going to need some help with this. Bill, could you help me with this?
Yeah, sure.
Appreciate it. Now, with this compass here, if we want to change the size of the circle, we just move the setting like so. Today, we're going to draw a special circle, so we need this big one. Okay, Bill? I think the best way to do it is just plant this pivot down here.
Set it up for me.
And you just move it around and just form a circle on the floor.
Okay, I think I can do that.
Now, way back in history, people discovered that there was a relationship between the distance around the circle, or circumference, and the distance across the circle, or the diameter. Okay, let's see if we can measure this circle. Okay, I'll take this in, you take that.
Okay.
See what you get.
Now, this says it's 7 feet across.
Okay, good, remember that.
Okay.
Now, I want you to, if you would, to measure the circumference of this circle, the distance around. Now, even though we just drew this circle, the diameter and the circumference have the same relationship to each other as all other circles everywhere have. Okay, see what the measurements are. What'd you come up with?
Well, this thing says that the circle is 22 feet around.
Okay, sounds good enough. 22. Now, what was that diameter?
7.
Okay, thanks, Bill. Now, what we have here is a numerical relationship between the diameter and the circumference. This is true of any circle you ever find anywhere. Now, sometimes we'll measure it in inches, and sometimes we'll measure it in centimeters. And also, this 7 units and 22 units won't always be there, but the 22 to 7 relationship will always be there. Remember we used to talk about numbers having many different kinds of names? Okay. Same is true of this 22 to 7 relationship. For instance, these all express the same thing, 22 over 7. Okay, now, someone might want to divide 7 into 22 and see what they come up with. And Martha, if you work this on your calculator, I think you'd find that the answer wasn't quite the same. Now, mathematicians figured that out centuries ago. What they decided was that the mathematical value of pi is this right here. But we usually write it 3.1416. Because it's not going to come out even anyway, so why go more than 4 places? Okay. Now, one thing to remember about pi. While it's not completely accurate, it works. Now, this rule of pi, works just the same in the real everyday circles we're trying to figure out as it does with this one here in the classroom. Now, we know that 7 is the diameter. So if we multiply 7 times 3.1416, we should come out with 22, or it'll be so close you really can't measure the difference. Now, Bill's already told us that the circumference is 22. So there we are. So, what we're saying is that pi is not perfect, but it works. It also happens to be the basis of geometry. That's all I got, Frank.
Well, good, David. Thank you very much. I think this should take the mystery out of pi, because now we know that pi is just a mixed number, and we already know all about mixed numbers, right?
Right.
Here are a couple of things to remember about pi. Pi is a number used to deal with measuring circles. The formula for the circumference of a circle is the circumference is equal to pi times the diameter. Don't let formulas bother you. The only purpose they serve is to give you a simple way to remember how to calculate different problems. All expressions for pi are approximations, but they work. The value of pi can be expressed for practical purposes as 22/7, or 3.1416, or 3 1/7. Here's an example of how to use the formula. Can you think of the circle problem as just another problem using mixed numbers? This is Steve Wise. See you next time.
Local funding for GED on TV has been provided through a grant from the employees of DLH Industries, manufacturers of fluid, air, and vacuum delivery systems for the automotive industry. DLH, committed to excellence in manufacturing and broadcasting.